folks, so today we're going to be looking at the acids, bases and neutralisation homework, specifically questions 1 and 6b, so please keep watching for help on these two questions. So here's question 1. 3 solution bottles have lost their labels. The solutions are potassium chloride, nitric acid and sodium hydroxide. Using your knowledge of chemistry, describe how each solution could be identified. So first things first, we should have a look and get some little labels ready. So we'll start off with potassium chloride, nitric acid and sodium hydroxide. So let's have a look and see if we know anything about any of these. So nitric acid is an acid, sodium hydroxide is a base, and then finally potassium chloride is a salt. So we can add them to universal indicator. So what would that look like? Nitric acid would turn universal indicator red or orange. Sodium hydroxide would turn a kind of blue or purple colour, and then finally potassium chloride would turn it a nice green colour. If you wanted to finalise your answer, you could put collect a sample of each solution, add to a dimple tile, add universal indicator to each, and observe what colour each solution goes. So we're going to have a look at question 6a first of all, because we need the answer of 6a to continue on with our calculation. Sodium carbonate solution can be added to water in swimming pools to neutralise the acidic effects of chlorine. Using the results in the table, calculate the average volume in centimetres cubed of hydrochloric acid required to neutralise the sodium carbonate solution. If you have a look at the table, we're only interested in these two answers because they are concordant. What that means is they are within 0.2 centimetres cubed of each other. So your average volume is going to be 15.9 plus 16.1 divided by 2, which gives you an average volume of 16 centimetres cubed. So let's have a look at 6b. It's the same first part as 6a, but we've got a little bit extra to the question. The equation for the reaction is as follows. Using the answer from part A, calculate the concentration in moles per litre of the sodium carbonate solution. So if we have a look at the question, you'll see that we have a concentration of hydrochloric acid, which is this in the equation, and then finally we have a volume of sodium carbonate solution, which is this in the equation. So let's split our page up. We'll do hydrochloric acid on the left and sodium carbonate on the right. So our volume from part A is 0.016 litres. Now I've turned that into litres. We also have a concentration of 0.1 moles per litre. So what does that look like? Your number of moles is concentration times volume, which gives you 0.1 times 0.016, which gives you a number of moles of 1.6 times 10 to the minus 3 moles. So now we're going to have a look at the balanced chemical equation. You'll see that we have a 2:1 ratio of hydrochloric acid to sodium carbonate. What does that mean? We're going to take the number of moles that we just calculated it and divide it by 2 to give us an answer of 8 times 10 to the minus 4 moles. Okay, so we're almost done. We've worked out that the number of moles of sodium carbonate is 8 times 10 to the minus 4 moles. We also have a volume in the question, which is 0.01 litres. We're interested in concentration, so that's number of moles divided by volume. Substitute in your values. We have 8 times 10 to the minus 4 divided by 0.01, which gives you an answer of 0.08 moles per litre. And that's us finished. If you've got any other questions that you want me to go over, please feel free to give us an email. Apart from that, I'll see you all later.